Hey everyone, welcome back with my YouTube channel. In today's video, we are going to talk about Array Steque, an interesting data structure that combines the both properties of both stacks and queues. But before we divide into what an Array Steque is and how it works, we must first need an understanding about fundamental concepts behind it. So in this video, we will start by getting a basic understanding of arrays, stacks and queues. Once we have a solid foundation, we will explore sticks, their operations, and why using array-based implementation is beneficial. Stick around till the end to see where an array stick can be applied in real-world scenarios. So, today's content is: what is an array? What is a stack and queues? What is stick? Why use an array for stick? Code implementation and explanation. Where can we use array stick? So what is an array? An array is a collection of elements stored in a contiguous memory locations. It allows storing multiple values of the same data type and provides fast access to elements using an index. Arrays have fixed size and enable efficient operations. So let's take an example, like imagine a list of student roll numbers stored in an array, where each student can be accessed using their position index in the array. So the common uses of arrays is storing and manipulating tabular data and used in searching algorithms like binary search. And so, what is a stack? A stack is a linear data structure that follows the last in, first out principle. It means the last element added to the stack is the first one to be removed. Let's take a real world example. Think of a stack of plates. When you add a new plate, it goes on top, and when you remove a plate, you take from the top. And another example is a stack of books. And these are the operations of stack: push, pop, peek is empty, and size. Push operation is as an element to the top of the stack. Pop operation is remove and return the element from the top of the stack. Peek top is returns the elements at the top of the stack. Is empty operations is checks if the stack is empty. Size means returns the number of elements in the stack. Stacks are used in various applications such as function calls management, undo and redo operations, and expression evaluation. So what is queue? A queue is a linear data structure that follows the first in, first out principle. The first element added is the first one to be removed. Let's take a real world example. Think of a queue at a ticket counter. The first person in the line gets served first. And these are the operations of queue. NQ, DQ, peek is empty. NQ adds the elements to the rear end of the queue. DQ means remove and returns the element from the front of the queue. Peek operation returns the front element without removing it. Is empty operation checks if the queue is empty. So now you all have a basic idea about stacks, queues and arrays. Now let's move on to what is a steque. So what is a steque? A steque is a combination of stack and queues. It's a hybrid data structure that supports three primary operations like push, pop, NQ. In the push operation, it adds an element to the front. In NQ operation, it adds an element to the back. And the pop operation removes an element from the front. Real world example for steque is task management, undo and redo systems. And these are the operations of a steque. So what is an array steque? An array steque is a dynamic data structure that combines stack and queues. Functionalities using a dynamic circular array. It supports three main operations: push, NQ and pop. By leveraging a circular array technique, it avoids expensive shifts and efficiently utilizes memory, with most operations performed in constant time on average. Why use an array steque? Using an array-based implementation for Steque provides fast access, efficient memory usage, cache locality, simple implementation. So now is the time for the code explanation. I have written a Java code for you. Let's begin. First to 11 lines. Defining an Array Steque class. It has an array ARR to hold the elements and three important variables front, rear and size to manage the Steque. We also have a constant capacity which sets the maximum size of the Steque. The constructor initializes the array with fixed capacity. The front and rear pointers are initially set to -1, indicating the Steque is empty. The size set to 0. Now let's move on to the push operation. Line 14 to 31. In the push method, the operation adds the elements to the front of the Steque, which is a characteristic of stack. When we push an element, we first check if the Steque is full. If it's empty, both front and rear are set to 0. If there is a space at the front pointer is simply decremented and the element is placed there. If no space is available at the front, when front is at the 0 index, we shift all elements one position to the right, then add the new element at the front. Now let's move on to the enqueue operation. Line 34 to 46. In this operation, it adds an element to the rear similar to the behavior of the queue. In the enqueue method, if the Steque is full, we print error message. If the Steque is empty, when front is -1, both front and rear are set to 0. If there's space, we just increment the rear pointer and insert the new element there. Now let's move on to the pop operation. Line 49 to 60. The pop method first checks if the Steque is empty. If it's not, it removes the element at the front pointer, increments the front index and decreases the size. If the Steque becomes empty after the pop, we raise front and rear to 0 to -1. Now let's move on to the display operation. Line 63 to 73. The display method is used to print the current elements in the Steque. If the Steque is empty, it will print a message. Otherwise, it will print the elements from front to rear. Let's move on to the main method. Line 76 to 89. In the main method, we create an Array Steque object and test the operations. Let's take a look at the sequence of operations. We first push 5, then enqueue 10. After that, we push 3. At this point, our Steque looks like 3, 5, 10. Then we pop the front element, which is 3, and the Steque become 5, 10. Finally, we enqueue 15, and our Steque is now 5, 10, 15. Where can we use an Array Steque? Like operating systems, managing tasks with mixed priority levels, undoing redoing system, storing actions for efficient undo and redo operations, customer support queues, serving VIP customers first while adding regular customers to rear, gaming applications, and data stream processing. In this video, we explored the Array Steque, a powerful hybrid data structure that combines the best features of stack and queues. We first built a strong foundation by understanding arrays, stacks, and queues, and divide into how a Steque allows both LIFO, last in first out, and FIFO, first in first out operations. We also discussed the advantages of using an array approach, such as fast access, efficient memory usage, and cache locality, along with the practical applications like task scheduling, undoing, redoing mechanisms, and memory management with its versatility. The array stick is an important data structure that can be useful in various computing scenarios. Hope you found this explanation helpful. If you did, like, share, and comment and subscribe. Stay tuned for more content. Thank you.